Thank you, Scott. Again, my name is Scott Myzak, Application Engineer at CAD Technology Center. Today's webinar, we're going to talk about Subassembly Composer. I'm going to walk you through the basics, intermediate levels, and then I have a subassembly already generated that goes through a lot of the complex um, functions of the software. And then once we get one of those built, we'll go ahead and show you how to bring it into Civil 3D. So we're going to work, what we're going to deal with today is we're going to look at the interface, the 5 windows within Subassembly Composer, the toolbox, the flowchart, properties, preview, packet settings. We'll go ahead and create a simple subassembly, and then we'll actually look at a very complex subassembly. Before we do that, I want to take a quick poll question. What is your experience level with Subassembly Composer? None. I struggle with it. I can create simple sub-assemblies without a problem. And then, hey, yeah, I know how to use enumerations, switches, decisions within the complex sub-assemblies. Well, it looks like we got a lot of people that have never used Subassembly Composer. That's great. You should learn a lot out of here. We got a handful that can make simple sub-assemblies. Well, hopefully after this, you'll still be able to pick up on some information. And then looks like we got 1 or 2 people that can create complex sub-assemblies. That's great. Maybe you should still be able to pick something up really nice off of this. So let's go ahead and get into the demo of subassembly. So first, we'll look at the windows. You have the toolbox over on the left-hand side, and this is where you're going to generate your points, your links, your shapes. And then within those, you also have some advanced geometry, like an intersection point. So I can say create a point based off of the direction of this link and this point, if that point was going at this particular slope. Curves, surface links, daylight roundings, get mark point, fillet arc. And then what's new in 2015 is the actual offset geometry. And then there's every now and then you're going to need to create construction lines or construction points. And that's what the auxiliary points are and the auxiliary links. They're just construction. They get you a point out there in space, but when you bring it into Civil 3D, they never show up. So they're hidden, they're turned off, they're construction only. It's great when you have issues that you need to find a point in space before you can start drawing lines. And then there's the flowchart, sequences and decisions and switches. Sequences are, I like to call them folders in Windows Explorer. I have my D drive, but then I have 5 folders underneath my D drive. And then underneath those 5 folders, I have something for Civil 3D, another folder for InfraWorks, another folder for Subassembly Composer. Sequences work the same way. In my example I'm going to build a curb assembly. Well, I want to create a sequence that has just the curb in it. Then I'm going to create another sequence that'll have the base or the rock underneath there. And then underneath there, I'll have another sequence that will be for the sub base or the sand. It's a way to make only 3 objects appear in your flowchart instead of having a list of all you need for the curb, all you need for the base, all you need for the sub base. It's a way to keep things organized and clean. Then some of the more complex, advanced are the output parameters, define variables, set mark point, and then there's a report message. Those come in really handy, and you'll see that in my advanced subassembly on how I predefine values for the curb. I want to know that the curb is always going to be, or the gutter width is always going to be 12 inches, 18, 24, 30, 36 inches in width. I don't want the user to have to pick a value, because I don't want someone to come in and pick a gutter width of 27 inches or 23 inches. There's standards for curb. Most of the curbs poured with a boot, so I want this thing to be based off of the boot. So setting output parameters, defining the variables, setting variable values will help me do that And those come in handy with the numerations, and we'll see that with my advanced. The next window is the flowchart. And this is how things are constructed. It is a flowchart. You start at the top where it says start, and then you go down the line. You connect point to point, link to link, and then with decisions, switches, you have the ability to branch off. Properties, we'll see the properties. I'll talk more about the properties once I start building my subassembly. You'll see the values within the properties. And then fourth window is the preview window. As I'm building this, you will see all my points, all my links, auxiliary points, auxiliary lines, and you'll see how it's being built. So maybe I accidentally put in a negative value when it needed to be a positive value. Well, in the preview window, I'm going to see my line going in the wrong direction. I'm like, oops, I made a mistake. It needs to be positive instead of negative. I quick change my value, and then I see that in the preview that things are going right. Then I have the last window, and right now it's set at the input-output parameter. What this will do is it will allow users within Civil 3D to assign the value of your parameters. When I originally build this subassembly, I'm going to build it so everything's hard-coded so the users can't come in and make any changes. Then I'll come back, I'll quick add some variables for width, depth, curb face, top of curb, and I'll come back and then change the values within my curb assembly. So then when I were to bring it into Civil 3D and I drop it into my corridor subassembly, the users will have the ability to make adjustments to it. The packet setting is how things are going to look when it comes into Civil 3D. Right now, my assembly name is going to be Assembly 2. Well, I'm going to call it Curb. No spaces in here. Civil 3D does not like spaces in the assembly name. It does not like spaces in the help file or the image. And with that description, I can just put webinar example. Description, it'll accept spaces, but the assembly name, help file, it does not like. If anyone has ever gone into a subassembly within Civil 3D and gone to the parameters tab, off that properties of the subassembly, in the bottom right hand corner, there's a help, and it'll take you to a document that'll explain what the subassembly does, what each parameter is defining, and how to make adjustments to it. You can add your own help file to your own subassemblies. Creating a help file in a CHM format is the best way that I have found. The HTML, the HTM doesn't work as well as I thought it would. Using the CHM, as from what I have seen, has been the best. And then the image. The image is the little icon that'll come in right next to the name of your subassembly when you drop it in on your tool palette. Target parameters, you have the ability to target an elevation, an offset, so horizontal distance, or a surface. So we got 3 different target parameters. We'll look at those later on. It's a way to, if you're doing a daylighting or a lane assembly, you can target a width. So then when you go into your corridor and you go into your target parameters, you have the capabilities of saying, hey, yeah, I want my lane to be 12 foot wide, but now with the target parameter, all I do is I say target this line, and it will allow the lane to then widen to match that line. Super elevation, left inside lane, left inside shoulder, outside lane and shoulder, and then same for the right side, left side. Those are the preview values, and then they have the enable preview. Event viewer, it'll just give you any errors. If you have a mistake in your subassembly, you'll have an event viewer in there. There are some complex things that you can put in, and if this value is greater than this value, you can actually have it prompt and say something at the command line. That is a quick overview of the 5 windows. So let's go ahead and get started. Like I said, we're going to build a curb, and I'm going to build min.dot spec a B612 curb right now. So what I want to do is I want to start out and I want to build a basic point. So I'm going to click and drag in a point. And now that I've got a point in there and I've clicked on it, so it's highlighted orange or yellow, I can see my properties. And the point number, P1. Type, delta X, delta Y. So change in X, change in Y. There's no other points in here, so it's got to be from the origin, and I want it to be 0, 0. The benefit to this is that origin is going to be your insertion point. So I actually have the capabilities of saying maybe -1, and that will actually come in, and when I insert that into my assembly in Civil 3D, it'll actually be a foot lower than wherever I click, because my delta Y is now a -1 foot. So I may want to have a proposed profile, but I'm only concerned about my datum. So I could actually say, drop this down 2 feet because I got 6 inches of blacktop, I have 6 inches of rock, and I have a foot of sand. And I could build my surface just based off of this. Well, we're building curb, so we want to leave this at 0 and 0. And I want to add another point. So I'm going to drop it in, and as you can see, it automatically connected point 1 to point 2. So it's building a hierarchy. It's doing an order. Well, what I want to do is I want to go point number, P2, delta X, delta Y, because I want to have it based off of a particular point. Well, right now it's giving me an option of P1 or the origin. Well, I want to go from P1. And here, I'm going to build my gutter. So what I want to do is delta X and delta Y. Well, my gutter is typically a slope. So instead of delta X, delta Y, I want to go slope and delta X. So now I'm going to say P1 is my starting point. My slope is going to be -6. And I like that it puts in 600% if you just put in -6. So I got to put in 0.06 for it to give me 6%. And then my delta X is going to be, like I said, B612 curb. So my delta X is 1 foot. And if I do fit to screen in my preview window, I now see a P1 on the left, a P2 on the right, and it's 1 foot apart horizontally at a -6% slope. Well, let's go ahead and quick build the face of the curb. So I'm going to drop in another point, and then this time it's going to be P3. I don't want a delta X, delta Y. This time I want a vertical change and then a slope. So instead of slope and delta X, I'm actually going to do slope and delta Y. From P2, because that's where I'm leaving off. Here's the nice thing is I can actually put in a slope instead of just a percent. So I can actually put 0.33:1, and it'll automatically adjust it to be 303%. And then because it's B612 curb, the vertical change is 0.5. Fit to screen, there's my face. So I'm going to quickly run around, add my top. Here, I'm doing my top of curb, so I'm going to go from P3, and this is just going to be delta X of 0.5, and I'm going to leave it flat. So now I have half my curb done. Let's go ahead and add one more point. And I'm going to build the depth of the curb. So delta X, delta Y, but now I'm going to go back to P1 because I'm going to start here. And delta X, I don't want it to move horizontally, but typical B612 curb is 7 inches thick. Well, 7 inches thick is 0.583, and I want to go down, so it's -0.583. Now I need to get that last corner in there. Well, I don't know the distance because I couldn't do the math because of that 1700ths of the face of the curb. So what I'm going to do is I'm going to create an auxiliary point. I'm going to bring in an auxiliary point, and this is a construction point. So AP, and it's going to give me a line AP1 or LL1, and I want to go delta X, delta Y, but I want to go from point P4 because I want to go from my top back of curb. And in here, I want to go minus 0.583 again. In this case, there is no wrong value. I just needed to get a construction line in there for AL1 that was right underneath point P4. So now that I have that auxiliary line, I can create an intersection point. So what I'm going to do is I'm now going to come in and create an intersection point. And it's called P6. And it's going to be, I got a couple options here. Type, intersection between two links, link point slope, or 2 points and a slope. Well, I have a link, AL1, and I have a point. So let's go link point slope. My link, AL1. My point, P5. Here's AL1. Here's P5. Extend link, yes. Slope, minus 0.06. Extend slope, yes. I have my point in there now. I need to go ahead and create 2 links. Don't need a point anymore because I have it. So I'm just going to drop in a link. And because it's a link, it says start and end from. And I want to start from P5 and end at P6. And I've just created the bottom of my curb. I'm going to put in one more link. And this link will go from P4 to P6. There is the outline of my curb. One last thing I want to do to it is I want to add a shape. Yeah, I could come in and I could add link, and I could just quickly go around and add L1 all the way up to L6 in there, but I can also click that little green box right there, click inside of it, and it'll automatically add all the links to it. So now I have a basic B612 curb outline. But let's say instead of B612, I want this to be generic, and I want to have the users to have input. I want them to say what is the gutter width, and I want them to have the capabilities of plugging in 12, 16, 18, 24, even 23, because they're just being different. So for me to do that, what I need to do is I need to have input and output parameters, well, more input than output. So what I'm going to do is I'm going to jump to my input parameters tab, and I'm going to create a couple parameters. I'm going to create 5 parameters. So I'm just going to go 1, 2, 3, 4, 5. First thing I want to do is I want to set my side to be left or right. It doesn't matter which one you choose, you just got to have a side, and it can't be none. I'm going to update parameter 2, and I'm going to actually call this gutter slope. Again, no spaces. Subassembly Composer does not like spaces. And I want my gutter slope, I want the type to be, in this case, grade, because it's typically 6%, and that's a grade. Slope would give me a 3 to 1 or something along that line. But as you can see under my types, I have a handful in there. Integer, double, string, grade, slope, yes or no, side. And then what's actually new in 2015 is super elevation, axis of rotation, slope direction, and potential pivot. So if you're building a lane, you can actually plug in these 3 values, and then on your links, assign axis of rotation. And then if you assign super elevation to your alignment, your subassembly will then account will have access or rotation built into it, speeding things up. Real nice feature in 2015, a lot better than how it used to be constructed in 2014. Well, gutter slope, I'm going to go grade. And input, the direction is input, and I'm going to come in and I'm going to put in 6%, minus 6%. Oops. And then it slope. Now my next value is gutter width. This time, the width is going to be an integer value. So double is the default for real numbers. So I'm going to take double because I could actually put in 25.2 input, and I'm going to leave it at 1 foot. My next one will be curb top. Again, it's a double, and it's going to have a default value of 0.5. Curb face, double. Oops, actually, curb face, my fault, has a slope. And in this case, for B612, the default slope is 0.33 to 1. And then I know it gets annoying, but every now and then, sometimes the parameters don't take and you have to enter them again. And then curb height, double, and B612 has a curb height of 0.5. So now I have those 5 parameters that I actually put in to build this. Notice I didn't put in the depth, just for the fact that that's typically how it normally is. It's always 7 inches thick. It's the top that changes. So now what I just need to do is, for like the line L1, it's hard-coded slope, minus 6%. But if I come in and change that to actually say gutter slope, now this line will take on the gutter slope that's assigned in my input parameters. Right now it's 6%. Well, let's take a peek at it there. That looks decent. And we'll see in the preview that if I make it a positive 6%, my line now goes up. So I make my adjustments in the default value, and my preview window automatically updates the changes. When you import this into Civil 3D, the users are going to see these 5 variables: slope, width, top, face, and height. What they see in Civil 3D will be what's displayed here. So here I'll actually say slope, and then description will be slope of gutter. And then I'd go on and say width, and then width of gutter, and continue on. So in Civil 3D, they would see slope and then slope of gutter. That's all fine and dandy. But what happens if you don't want the user to have the ability to set a particular width? You want them to be predefined, and then maybe you want them to only be able to choose values of the standards of B-style curb or D-style curb, S or V from MnDOT specs, or Wisconsin DOT, or North Dakota, South Dakota, Iowa, or whatever state, county, municipality that you're dealing with. This comes into our complex subassembly for this. So I'm going to go ahead, and I got one already created. I'm not going to save that. So what I have is I have a MnDOT spec curb. And what I've done is, the first thing I needed to do was I needed to come to the View tab and define enumerations. And I made 2 enumerations. I made a curb style, 4 styles of min.curb, B, V, D, and S. I gave an enumeration item value and a display name. And then through the DOT specs, it says that there are only 5 gutter widths, 12-inch, 18-inch, 24, 30, and 36. Well, the problem with enumerations is it cannot start with a number. Enumerations can't start with a number. Kind of silly, I know. But it's just the way it is. So that's why I have an underscore in front of my numbers, because an underscore is not a number. So I got gutter width, I got a 12, 18, 24, 30, 36, and then a display name, 12, 18, 24, 30, 36. So I made enumerations. Next thing I needed to do was I needed to come to the miscellaneous and the workflows. First, I created a sequence, dropped it in to start, and I called that sequence define variables. It's really nice. You can click on the header and you can add a value in there. So now my thing is CTC define variables. And this is my sequence. And I mentioned this before, they're kind of like folders. Well, I only see one object there, but if I double click on it, it actually opens up, and now I actually have 4 values in there. And that's what I did was I created a sequence, and then I said define variables. So I dropped 4 variables in there. Well, I don't need that one in there, so I'll just go ahead and delete it out. There we go. So what I did was I came in and I said gutter width, and I gave it a value of double, just like I did over on the other example. And then curb height, double, face pitch, double, top depth, double. So I have 4 values that define 4 inputs. Then what I did was I created a switch. And what this switch does is it says take the input parameter style and take the value of it. That's what the dot value means. It says input parameter, name, style, and then give me the value. Well, if I come over and look at my style input name, it has a type curb style. Well, you know what? That curb style, it wasn't there before. That's because once you go ahead and create an enumeration, it becomes a type. So that's why I have curb style and I have gutter width 1 as 2 new values besides the other ones. Well, I say curb style is my type. I say it's an input parameter, and then I say the default value, B. Well, the input default value, I only have 4 options, B, V, D, and S. I don't have the option to put in anything that I want. That's the benefit of an enumeration. So in doing so, now the end user in Civil 3D can only pick those 4. Same thing with the gutter. I defined the type as the enumeration gutter width 1, and within there, it's now 12, 18, 24, 30, 36. So I made a switch, and what it did was it said, hey, take the value of style.value. Well, in this case right now, the value is B. So it's going to say, hey, let's follow this line. Because if I open up the switch, it says expression style.value, and that's what it's saying here. Now if I look at the link leaving the switch, the case or the value is B. So if the value is B, it's going to follow this line. If it's S, it's going to follow this, V, and then D. Well, this went into another switch. This switch has the gutter value. So if I open up switch, it says expression gutter.value. Well, my gutter right here in my input parameter has a default value of 12 inches or underscore 12. So it's going to follow this line out for 12. I got another one if the value is 18, 24, 30, or 36. So switch 1, what style of curb? Switch 2, what is my gutter width? 2 values that I want the user to only have a predetermined choice of what to use. From there, I created another sequence, little icon, sequence, type, sequence, and I named my sequence B612, style curb. If I open it up, where I define my variables at the beginning, I now set the variable values. So here I said now my gutter width is 1 foot. My curb height is a half a foot. The face pitch is 3. The top depth, or the top of the from top face to top back, is a half a foot. I define those values right away. So I set the values, and then I come down to the geometry. And this is where I now build. Here's my curb. P1, delta x, delta y. Simple enough. P2 and L7. Slope and delta x. Now the slope is my gutter slope, because that one I can actually hard code -6. But now my delta x is gutter width. Well, I don't have a gutter width in my input-output parameters because that gutter width is right here. It's predetermined. So I'll jump back into curb, and it works its way around. There's the face of pitch, there's the curb height. So all those values that I predetermined are getting those values. And if I jump back in to B618 curb, now my gutter width is 1.5 instead of 1 foot. This, because the values are assigned here, when it comes down to the geometry, those are the values it's taking. So with the capabilities of a switch, I was able to determine what style curb to use. And then after the curb, I went to what was the gutter width, assigned the values, and then built the curb based off of those values. Worked myself around. Everything looks the same. There's my shape. But then I came in and I created a base. I need rock under there. So P7 to L11, that's just the depth of my base, predetermined by an input-output parameter. The user has the capabilities of seeing in civil. There is an overhang. So how far past back a curb do you want it to overhang? P9 to L13 is just the depth again. L4 is just connecting the two up. And then S2 is the shape. Subbase I had to do a little bit different. I still put in a depth, but then I needed to put in an auxiliary point because I needed to know where the back of curb was in relationship to the top of the subbase. So I put in an auxiliary point 3 that was an intersection of 2 links. And it went from L6, which is the back of curb line, and L14, which was the line, the link that was connected for the bottom of base. So it found that AP3 point for me right there. Again, it's construction only. It won't show up in your assembly. I then created a point P11, which was slope and delta x. The slope was gutter slope, -6%. Delta x was subbase overhang. And that point was generated from point AP3. So from here, it went from here at -6% for the subbase overhang, which was a foot. And then from there, it's connect the dots from P9 to P11, P11 to P12, which is the depth, and then connect the bottom up, and then add an overall shape. Let me shrink this down just a little bit so we can see a little bit more of it. So, with the complex curb assembly, first you define variables that you want to be hard-coded based off of 2 enumerations, the curb style, the gutter width. create a switch for what style of curb, create a switch for each style you have. If you have 5 different styles of curb, you'll have 5 switches. I have 4 styles of curb, I have 4 switches. And then from each switch, it's how many, what are your enumerations for gutter width. You'll see that I have 5 for B style, I have 5 for S style, 5 for V style, but I only have 3 for D style. The benefit to doing this is if I come in and in Civil 3D, I use D style curb and I say 30-inch curb width, the subassembly will actually not build within Civil 3D. So it's a safety net telling me that, hey, this won't work. So once I've built the 4 switches and then defined a link coming out of each for the acceptable gutter widths, I then assign the values. I'll look at my S-style curb really quick, and now I have gutter width of a foot, face pitch 0.66, that's different than B-style. The curb height 0.412 or 0.416. Again, that's different. Top depth 3300ths. Different values will be built based off of whatever style I pick. And you'll see that if I switch the style in the preview. And then if I go to V, you'll see what it looks like in V, and then you'll see what it looks like in D. That quickly it makes the changes. And then I built the geometry. Now that I have everything built the way I want, I'm going to take a quick look at the packet settings. And in this case, my subassembly name is min.curb 140227. Meant the last time I updated this thing for my own records was February 27th of this year. I created a help file, and I have an image. So now what I want to do is I actually want to bring this into Civil 3D. So I'm going to quick jump into Civil 3D, and I'm in 2015 right now. I have my tool palette open, and what I want to do is I want to say right-click on the bar and say import subassembly. Source file. Well, I got this thing stored on my desktop right now, so I'm going to bring it in. And I'm going to say, okay. And there it is. That display name, it said min.curb 140227. If I pull that out a little bit more, looks a little bit better. And then I added an image of our CTC logo. Kind of quickly, oops. Get cycling through here. I accidentally shut down my ribbon. Let it come on. It's coming. There we go. Now hopefully it doesn't change on me. So sorry about that little delay. Now I'm going to create a simple assembly. And we're just going to call it the default. Say okay. Drop it in. And I now have my assembly. My min.curb. I'm going to pick it. Opens up the properties window like normal. And I see side, right, curb style. We're going to go with B style curb. Gutter, minus 6%. Gutter width, 12 inches. Bottom slope, minus 6%. Just in case it was gutter out. Sub-base depth, sub-base extension, base depth, base extension. All the parameters that the user can adjust. I'm going to go ahead and just drop it in. There is using the out-of-the-box template, dropping in my assembly, I see my curb, I see my base, I see my sub-base. Subassembly properties, parameters tab, let's switch it to be D-style curb, say OK, say apply, I see it update automatically. Let's go ahead and change that to be 24 inches, say OK, say apply, I see the value update. Now, in my subassembly, the 30 and the 36-inch gutter width was not acceptable. So if I come in and I actually make this 30 inches and I say apply, whoops, okay, and I say apply, it disappears because it tells me that it's not available. So it's kind of a check. That way your engineer doesn't accidentally build D-style curb that has a gutter width that's not usable. So I'll go ahead and move this back to 12 inches, say apply, and drop it in. I have subassembly help. I mentioned that CHM file. Well, I came in and created my own CHM file, and I dropped in some imagery, but it tells me this subassembly creates a cross-sectional representation of one of the 4-style mid-dot curbs. It shows me the B-style, D-style, S-style, V-style, and it gives me the available gutter widths. It then breaks down, it gives me a quick screen cap of the parameters, and then it gives me a definition of, hey, the curb style. What values are there? Gutter slope, the slope of the gutter in a percentage, gutter width, predefined variables of 12, 18, 24, 30, 36. Bottom slope, it tells me what each input value does. And as anyone has used the out-of-the-box full gutter assembly, their dimensions are A, B, C, D, E, F, and G. Well, what's dimension G? Well, if you don't know, you have to go into this help and print out their little schematic that says, hey, dimension G is actually for this. Instead of it saying, hey, this is the gutter width, or this is the top of curb, the depth of the curb. This spells things out a little bit more. So a little help file spells things out for you. The next thing I did, which I didn't mention when I was in Subassembly Composer, was I actually had point codes and link codes that I assigned within Subassembly Composer. Well, my link codes, I got one for base, I got sub-base, none, datum, I got curb, and I got top. So when I build my surfaces, I want the top of my curb to also be known as top, because when I build my finished grade surface, I'm using all the link codes that are called top. My shape code has a curb code in there. So if I'm doing a material quantity takeoff, I assigned a shape code of curb. I also assigned a shape code for base and sub-base. These codes are out of the box default naming, so curb, base, sub-base, and then my link codes are curb, top, base, sub-base, none, and datum. And then I have point codes. I now have point codes within civil for flange, flow line gutter, top curb, back of curb. So if I jump back into my subassembly composer and I jump into my geometry, and I look at my curb, my point P1, which is my gutter tip, it has a point code flange. P2, L7, let me open that up, has a point code of flow line gutter. P3, L8 has a point code of top of curb. Those values being assigned here, both point and link codes, gives me the ability to then use it in Civil 3D for my code set style. I can assign pay items to it. I can assign materials to it. And then I can use it for building my surfaces, and I can use it for pay items. Oops. Let's get back to civil. And that's basically all I have for you is how Subassembly Composer works. I started out building everything so it's out of the box. There's no user intervention with it. Everything was hard coded in. I plugged in 1 foot there. I plugged in um, 0.33 to 1 for the slope with a delta y of a half a foot. I then went in and showed input output parameters that gave users the capabilities. I'll say cancel there. Oh, I was actually still in it, so I didn't need to cancel it. So I had my parameters. This gave the user the ability to change values within it. I then opened up and showed my more complicated curb subassembly that had predefined values for mid-dot specs. And that had enumerations and then switches. So user will automatically predetermine the slope and the face, the height of your curb based off of what style they use. And then once it was done, we went in. I had a help file already created based off a CHM file format. There's a nice video out there on YouTube that if you say create CHM file, it's a 5-minute long video, but it walks you through every step. I watched that and literally had no issue creating a CHM after that. I added an image. I said, clicked on the header or the bar, import subassembly, navigated to where it was at, dropped it in. If there are spaces in the help file naming, if there's spaces in the display name, if there's spaces in the name of the file itself, Civil 3D will have an issue bringing it in. And if there is a space and you go to the help file, it's going to say, hey, I can't find it. That was one way of bringing it in. The other way is under the insertion tab. If my screen will catch up with me here, is import subassembly. So there's 2 different ways to get to it. So we'll take questions right now. I do have a couple questions already. Can I copy and paste elements from a flowchart? Yes, you can go ahead and you can copy elements from one to another. There is hierarchy with your flowchart, though. You cannot reference something that was created after it. So if I created a link L1, 2, 3, 4, and 5, and then I want to create L6, or yeah, I create L6, but now I want to have line L4 be referenced to that point that was created in L6. It won't do it. It has to be done prior. So that's why when I was creating my points, and I look at point P5 right here, delta X, delta Y, my options are P1, 2, 3, and 4, but not P6, because P6 was created after. But I can come in and say copy, and I can come in and click right here and say paste. And it took the same values of this one and dropped it in here and automatically created a brand new P number and L number. You can copy and paste an entire sequence. That comes in handy when you're dealing with my sequences for defining the variables of the gutter width, face, pitch, depth. I copied the sequence and then just pasted everything in. And then all I had to do is do the quick change instead of saying create sequence and then set variable value 5 times with 4 variables in each. It saved me a lot of steps. For example, decisions that are past the switch have similar characteristics, but same edges. Yes, you can copy that switch and paste it in. And in that case, what you do is copy, paste the switch. And what it's going to do is it's going to remember. Sometimes it will remember, sometimes it won't. And now I have a new switch with the same gutter value. And then what I just need to do is create a link. I'll create a link coming into here. And now this is actually leaving the switch. So here I would assign a value of, well, I have nothing assigned but B24, or actually in this case, underscore 24. Delete it out. And if I come the other way, let me break that link. Delete that. Delete that. Come on, delete. If I come out of the sequence and then into the switch, then it knows which way you're going. So you have to, when you connect your links up, it knows where you're starting from and it knows where it's ending. It's not that you can't just right click and say reverse direction. So it is possible to do copy and pasting. And then the last thing, I'll do a quick show. The new feature in 2015 is the ability for axis of rotation. Apply AOR right down here under the link. You check that, and then in your sub-assemblies or in your corridors, if your alignment has super elevations, it will then take on those parameters. Now, in this case, if this was a lane or I wanted super elevation to be applied, I have to apply that axis of rotation to L7, L5, L14, and L18. I have to apply it to all 4 horizontal lines, and actually technically L8 too. So if I'm doing a lane, you need to apply axis of rotation to all 4, and then insert those 3 input-output parameters that are slope direction, potential pivot, and super elevation axis of rotation. I don't have any other questions, so let me talk about our upcoming events. We have a workshop a week from Tuesday, talking about complex corridor subassemblies. We're going to talk about doing conditional, found, not found. We're going to talk about cut fill analysis, targeting, how you can create one corridor with one region and have multiple outputs. We then have a workshop the 17th of June talking about pressure network part building, how to take a civil 3D object, well, not a civil 3D object, a AutoCAD solid, and generate a pressure pipe network out of it. And then June 24th, a week later, is actually talking about part builder using the storm or sanitary content builder, using part builder to build parts. And then we have 2 webinars coming up June 3rd and 9th. First one is on pipe networks. The second one is on pressure networks. Lo and behold, if you look, we got workshops that follow up those webinars. Are there places to obtain road subassemblies that have multiple slopes per strata plus benches? As of now, in Minnesota and Autodesk, no. There isn't a way to, there isn't a location to find PKT files. Rumor has it Autodesk was getting all the out-of-the-box subassemblies that were in a .NET format, and they paid someone to put them in a PKT format. Allegedly, those are going to be made available for manipulations. Eventually, we will have a couple of these subassemblies, like that curb subassembly that I just demonstrated. We'll have that up on our website. It's got a little fine-tuning to do. I got one for multi-variable lanes. We got one for curb with a sidewalk option behind it. We have 7 or 8 that should be made available on our website in the near future. But as of that, No, that's all there is. Um, no other questions. So again, thank you for attending. I have my contact information on here. Visit our website, cadtechnologycenter.com. My email address, scottem@cadtechnologycenter.com. The direct line to our office, 952-941-1181. One other question. Is there a way to display to the user a value computed based on two values that are inputted? Yes, that is under um, the the editor. You can compare two values and then have it display the output. I don't have anything set up right now to show. Um, with that, I again thank you for watching. I'll stay logged on for a couple more minutes if any more questions pop up. But we'll see you at our next webinar. Thank you.